Students, welcome back. Now let's continue with our classification of routing protocols. In the previous video, I just given the introduction of these classifications. So whatever I explained so far, I just place it, show it in this diagrammatic. So the routing protocols for ad hoc networks are classified into 4 types based on routing information update, based on the use of temporal information for routing, based on topology information of organization, and some the resource specifications, utilization of specific resources. Okay, based on the routing information, it's divided in table driven, which is a proactive, reactive, on demand, hybrid. And temporal information is the path selection, means the present and the future. Okay, and the prediction, is there any the lifetime of the battery, everything will be on this based on temporal information. And based on topology, flat routing and the hierarchical routing. And this utilization of specific resources is power aware routing and the routing using geographical information. So like that. So for each and every routing, there are different protocols that we are using. Okay, these are all the different protocols. So don't be panic. I'm not going to explain all these protocols. So in the exam also, you are not going to explain all these protocols because it's very lengthy topic. So for you people, whenever they ask about the proactive, try to explain 1 or 2 examples. On demand, try to explain 1 or 2. So I'm just taking the most important routing protocols for each and every example. I'm taking 1 or 2 important routing protocols. So first, let me take this first one. Let me call 1A, 1B, 1C. So this is 1 and this is 2, 3, 4. So with avoiding the confusion, I'm just taking this number and this relate to 1A, 1B, 1C. Okay. So we discuss about this 1A. That is a table driven proactive. So in the table driven proactive, what is the first example? So this is example 1, 2, 3, 4 like that. So in this table driven proactive, I am taking the first example, which is a proactive DSDV. DSDV. I am taking the first example DSDV. Now we are talking about the table driven proactive. So the first one is what is the first one? Based on the routing information update mechanism. The first one is based on routing information update mechanism. So this routing information update mechanism is of 3 types. Table driven, which is a proactive, on demand, reactive, hybrid. So in this video, I want to explain about the table driven and proactive. The table driven proactive routing protocols. So the different examples I am taking in this table driven or proactive is DSDV, WRP, CGSR, STAR. Okay, so I'll explain some examples here. The table driven or the proactive routing protocols are of the different examples are destination sequence distance vector routing, wireless routing protocol, cluster head gateway routing protocol, source tree adaptive routing protocols. So let's take the first one, DSDV. So we are talking about the based on routing information. The first one, 1A example. In the first classification, I just taken 1A and in that 1A, the example. Destination sequence distance vector routing protocol. So the destination sequence distance vector routing, the name itself is saying that we have to reach the destination in a sequence distance vector routing process. Actually, this is the enhanced version of the Bellman-Ford algorithm. So you already know the Bellman-Ford algorithm. If you don't know, just please check in the education for you. Just start the Bellman-Ford algorithm. You will see that. Okay. You can see that video. Actually, this DSDV is the enhanced from distributed Bellman-Ford algorithm. Here, each node maintains the shortest path node to the destination. So, whatever the nodes that are participating in the communication, so here each node, whatever the node you are taking, each node is maintaining the shortest path to the destination. So, to reach the destination, it maintains the shortest path. Incorporate table updates with increasing sequence numbers, like it prevents loops, counter the count to infinity problems, and faster coverage. So why we are using these routing tables? Because to incorporate the table updates with increasing sequence number tags. And this DSDV exchange table between neighbors at regular time intervals. So this is an important, because we are dealing with the wireless communication. The wireless communication means the topology will be changing dynamically. So the exchange table between neighbors at regular time intervals has to be maintained. There are two types of table updates in DSDV. So what are the two types of tables that are present in DSDV? So let me explain those two tables. So one is this. So the two types of table updates are incremental update and full dumps update. So in the incremental update, in the routing table, it takes a single network data packet unit, that is NDPU, single network data packet unit. So when no significant changes in the local topology, it's just take a single network data packet unit. Suppose if there is a change in the topology, so that is a full dump update. In the full dump update, it takes a multiple network data packet units. So there is no significant change in the topology means you can go for the single. If there is a multiple changes in the topology, we have to take the full dump updates. So here when local topology changes significantly or incremental updates required more than network data packet unit, you have to go for the full dump update. Okay, so this is just an introduction of this DSDV. Now let me take a simple example to explain how the routing will be established in this protocol. So let me take the example of DSDV. Okay, so here I am taking a nodes 1, 2, let's take 3, 4, 5 and 6. So this is the topology I had taken. Here let me take, this is the source, 1 is the source and 6 is the destination. So for each and every node you have to be calculated. So let's consider the node 1. So from node 1 you are traveling. You are going from node 1 and you have to reach the destination 6. So how you are going to take the path? Let's see the DSDV. It consisting of the destination, the next node and the distance you also calculated. Okay. So let's take this. Suppose 6 is the destination. Okay. Let's take 6 is the destination. So what is the next node for the 6? From where it is coming? The 3 is the next. Because the 5 means from 1 to 5 means it has to go like this. So it's better to take directly 3. So 6 is the destination means the next is the 3 and the distance from here is 1 and 1. One link and another link. So distance is 2. Okay. So let's take the destination is, let us take 5. So from 5, what is the next node? The node is from where it is coming, 3 or 4. So it just obviously takes 3 only, because from source to, if we take this path, it is almost the long distance. So just take the shortest distance. So the next is 3 and here also the distance is 2. If you take the destination as a 4, if you take from source, from node 1, if the destination is 4, if you think it is a 4, okay, because if the source wants to reach the destination, it has to reach first this destination, next this destination and this next, like that it has to be reached. So in this routing table, it's check which path is the best path and in that way it will go. Suppose the 4 is the destination from source to here. So from here to here, what is the path? Which path it will be selected? So the next node for this here is the 2 only and the distance is 2. Suppose if 3 is the destination from source to here, from here to here, if the node wants to travel, the packet wants to travel, the next is 3 itself, because 1 is the source itself and the path is 1. If you take 2, the next is 2 itself and the Distance is 1. So this is the routing table for the distance vector DSDV. Okay, this distance vector. So here I taken each and every node as a destination and I chosen the path from source. Suppose a single link break leads to the propagation of routing table updates through the whole network. So let us assume a single break is there. Let us take here the link was break. So whenever the link was break, the route has to be maintained in DSDV. The route has to be maintained again. So while it performing again, it is dynamically changing. The route has to be dynamically changed. How it is going to be changed? So when a neighboring nodes preciously a link break means the node here the link break is observed by the node 3. So whenever the node 3 is observed, it sets all routes through a broken link to infinity. So this whenever the link break is occurred, the 3 is automatically sets all the nodes as a routing link to infinity. And this link it make it as a infinity. So the broadcast to its routing table. So the node 5 receives an update. So whenever the break is there, the node 5 receives an update message like it informs the neighbors about the shortest distance to node 6. Okay. So the node 5 is intimating, so the shortest distance to node 6 is from my side only, and like that it is intimate to every nodes. This information is propagated through the network and all nodes updated their routing table. So whenever this information is received, all nodes is going to be update the routing table. Okay. So now it becomes how the path will come. So whenever there is a link is break, the node that may now send their packet from through the routing 1, 3, 5, then 6 instead of 1, 3, 6. Okay, means it selects a path like this 1, 3, 5, 6 instead of going this path. So it select the path like this, and it is going to update here the 6. It is going to be changed. The next node for the 6 is not 3, now it is 5. Okay, and the distance is changed to 3. So like that it is automatically updates. So this is about the DSDV. So here the advantages are route setup process is very fast and makes the existing wired network protocol applied to ad hoc networks with fewer modifications. Then some disadvantages also there here. The disadvantages is excessive control overhead during high mobility. There should be an excessive control overheads during high mobility, and the node must wait for a table update message initiated by the destination node. So each node has to be wait for the table update. After the link is broken, each node has to be wait for the table update message initiated by the destination node. So this is about the DSDV. Thank you.